One way to think about repeating a pattern core is to think of it as the translation of a shape, the pattern core, along the grid of the template. We also started to think about what would happen if we reflected the core. The students initially thought about creating a 10-column chevron pattern and then reflecting it over a line of symmetry. With Christina's help, they built a chevron pattern up to the 10th column and then worked to build the reflection from the 11th column. This was tricky and involved a lot of spatial reasoning. They then reversed the direction of the chevron and reflected that image. We then asked students to build a square pattern core that was itself not symmetrical to see if they could predict what the reflection would look like. They then created designs by reflecting one pattern core across the template. An interesting question once the template had been completed was, what is the pattern core? Students also explored what happens when a square pattern core is rotated around its center. Technically, it's a rotation and then a translation. They discovered that they could rotate their pattern core a quarter turn each time, so they could make 3 quarter-turn rotations of the original core on one template. One interesting thing they noticed is that sometimes a pattern core can be rotated, but look like it's been reflected, as in the diagonal pattern seen here. Students practice mentally rotating the pattern core and then use the interactive whiteboard to physically rotate the core to see what the resulting pattern would look like. Depending on how symmetrical the core was, the core sometimes looked the same when rotated 180 degrees, or a half turn, and sometimes did not. Research tells us that spatial reasoning skills, including mental manipulation and spatial visualization, are linked to mathematical achievement. We found these activities of predicting and creating two-dimensional transformations provided opportunities for students to engage in visual spatial thinking.